Okay, welcome back to section 6.3, page 2. We're going to have quite a few theorems on this page. Theorem 6.3.3 says, the perpendicular bisector of a chord contains the center. So here's our line. It is perpendicular to the chord, and it bisects that chord, then it contains the center. So if L, it's a perpendicular bisector, so L has to be perpendicular to the chord PQ, okay, and L bisects PQ. Then what can we conclude? Then we can say that L contains the center. How about passes through? I think that makes a little bit more sense. Passes through the center of the circle. Okay, let's go on. So basically we're getting the converse of that theorem of before in two separate theorems here. All right, let's go ahead and do theorem 6.3.4. It says, the tangent segments to a circle. So here's a tangent. Here's a tangent. Remember, tangents touch the circle at only one point. They're from an external point. So here's our external point. Are congruent. Okay, so that means that this is congruent to this. So AB is congruent to AC. All right, next theorem. If two chords intersect within a circle, so here's a chord, they intersect inside the circle, then the products of the lengths of the segments of one chord is equal to the product of the lengths of the second chord. Okay, so the segments, here's a segment and here's a segment. So if we look at this one chord here, we're going to say the product, that means multiply. So we're going to say RV times VS. So we're taking this piece here and that piece there and multiplying them. And that's going to be equal to the product of this chord segments. So TV times VQ. Okay, now notice here I did not put the bars above because we actually want the lengths. Okay, let's use this information in the next problem here. It says, given that DE equals 12, okay, so let's go ahead and say DE equals 12. Let's put that one in pink. Okay, and we'll say that's 12. Okay, and then we're going to say EC equals 5. Okay, so that one is 5. And then AE is 8. Okay, so that one, get a little bit over here, is 8. All right, so we're supposed to find EB, okay? EB. So what do we know? Well, if you notice, this is an example of what's happening above. We have two chords intersecting in the center of the circle, or not in the center, inside the circle. And it says that if we multiply the segments, they have to be equal to each other. So if we multiply this segment times this segment, that should equal this segment times that segment. So let's go ahead and do it. So we're going to say DE times EC, okay, DE times EC is going to equal AE times EB. AE times EB. Let's go ahead and plug in the things we know. We know DE is 12. We know EC is 5. We know AE is 8. And we don't know EB. That's what we're trying to find. So that's going to give me 60 there is equal to 8 EB. If I divide by 8, what do we get? We get that EB is equal to 60 over 8. They both have a 4 in common, so I'm going to divide by 4. Let's see, let's write it over here. 60 over 8. let's say divide by 4, divide by 4. Then I get 15 over 2. So either that, or we could say EB equals 7.5, whichever you like best, or 7.5. Okay, so that answers that question. So that's the end of page 2.